So today I'm going to teach you how to do this problem. So we're going to start off with number 1. So we're trying to find out x. We have two angles in adjacent length. So to find this, we can't use cos or sin because it's going to use the hypotenuse, so we're going to have to use tan. So we're going to go tan 40 equals opposite over adjacent. So it's gonna be this whole thing rather than just x. So we'll call it W. So we'll call tan 40 equals W over 87. That's this whole line right here, this whole one. So I'll put that in, and then to get this, we'll times 87 by this. So times 87, and we'll just equal W equals 87 tan 40. Okay, and then we'll put that in my calculator. Okay, and then you get 73.001. So just put 0. So equals W. So 0.001. So, but we need to find x, and the only other angle we have is this one right here, where we have this side length. So if we find this side length, we can subtract it from 73.001, and we'll find x. So we should do the same thing. So we'll go tan 25 this time, because that's the angle right there. 25 equals, we could just call it a random thing. We'll just call it L over 87. And we're going to do the same thing. We're going to times this by 87. It's going to be just L. And 87 tan 25. I'll do the calculator. It's going to be 40.569. So 40.569. So we have this whole one. It's kind of 40.569. So we subtract these two and we'll find x. So 73.01 minus 40.569. Just put that in the calculator because why not? It's going to be 32.432. So 32.432. And that's to the nearest foot, so we'll go 32. 32 feet is our final answer for this problem. Now we're going to solve number 6. So for this one, we're trying to find maximum height of the diver. So the y. Find this first. We can use this formula, negative b over 2a, to find our x, which we'll input to find the y, which will be our maximum height. So if we do negative b over 2a to this right here, we get, I'll just simplify to 8 over 3. So negative 8 over 3 over 8. Wait, yeah. 8 over 9, negative 8 over 9. So to this, we'll just go like 8 over 3, and then we'll do reciprocal times negative 9 over 8 is 72, and 24, and it'll be 3. So we can put our x as 3, and to find our maximum height, which is our y, we just need to input the values now. So simply we would just go, this is 3 squared is 9, so we go negative 36 over 9 plus 3 times 24 is 72, so we do 72 over 9 plus 12. So this is 8, this is 12, and then this is -4. So it's going to be -4, so 4 plus 12 is 16. And 16 is our maximum height of this diver, so we'll do 16 feet. And if you wanted like the exact coordinates, you could go 3, 16, because we got our x earlier from this. And now we got our y. That's how you solve this problem. So now we're to solve number 8. So for this one, we'll be using volume. So we're given these dimensions 2, 3, and 4. And we're trying to make a new bin, this is our normal bin, 2, 3, and 4. And we're trying to make a new bin that holds 5 times as much food as our current bin, which is 2, 3, and 4. So to write our new volume equation, we're not going to write the exact values. We're just going to write our function. So v equals length times width times height, which is the same for all. That's always what the volume is for rectangles and squares. And then we're going to need to increase it to hold 5 times as many. So we're just going to simply just go like this. And we're done with that part, so we can just circle it. And then the dimensions of the new bin. So simply all we're going to do here is we're going to put our dimensions 2, 3, and 4 in this formula. So 6, 24 times 5 is going to be 120. So 120 feet. And we can't forget to cube it because it's in volume. And 120 feet cubed is our final answer for this one. That's it.